Welcome to the very first episode of Quantum Podcast with Jay Shah. I'm your host, Jay, a quantum machine learning researcher. Today, we have with us Javier Mancilla Montero, who is a PhD in quantum computing. He is also the co founder and CEO of Falcondale. In this podcast, we discuss effects of quantum computing on financial institutions, finance professionals, and common people. We also talk about quantum careers, quantum AI, and much more. Hi, Xavier. Thanks for joining us today. And, the very first question is that you are a PhD in quantum computing. What is your story of quantum computing? How you got into the field, like how it caught your attention?
Yeah, first of all, thank you for having me here, Jay. In terms of my journey until I reached quantum computing, I started with machine learning actually. And when I say quantum computing all the time, of course, I'm aware of hardware and other things that the market is moving forward, but mainly my approach is machine learning. I started previously in other companies and personal projects or even startups working from the side of machine learning and mainly related to the finance sector in the last 6 years, 7 years. And at some point, I said, I'm looking for the next step. I was curious not only about quantum computing, but quantum mechanics itself, like playing with these subatomic pieces and atoms that probably will change our world in the future. So I start saying, okay, how if we investigate a bit what we can do with this and how this can be beneficial or have utility. Recently, IBM is talking about utility or advantage,
Mm.
right? And I start discovering quantum computing and start learning about Qiskit. I always think that the approach is more the reverse engineer because if you start straight with quantum mechanics, it's like a rabbit hole. You will keep going
Yeah.
there in an endless journey, trying to understand things that people with a lot of experience are not understanding yet, right? My approach was okay, let's start coding right away. I was coming from the machine learning side, classification models, credit scoring, and so on. So I said, okay, if we try something with Qiskit, if we start with variation analysis, we start with quantum kernels, and when you start coding, you discover, oh, okay, things are happening, or the results are good or not that good. And from there, you start the reverse engineering, understanding why this is happening in this way, how it works, what will be the difference between using one hardware or the other, and some other techniques. So I started in that way. And of course, I need to start studying. I started with some particular courses, start reading. At some point, I said, okay, I want to go to my PhD. Actually, my master degree is in data management and innovation, but I want to jump to quantum computing. I did my PhD but mainly, even if I need to go through different fields and layers of the quantum computing, my approach was always quantum machine learning, following the line of machine learning applied to finance. Actually, my doctoral thesis is about applying QML for credit scoring and also using not only classification models, but also feature selection.
Yeah, I mean that's interesting to hear because that's how I got into quantum computing as well from the side of machine learning.
Yeah.
That's really interesting. And if I can talk about Falcondale, so what are the things you are doing there in quantum finance?
Yes, at the beginning, we started Falcondale thinking that Falcondale can be just open source. So just provide a like pip install approach of a package or SDK that everyone can use. Imagine that someone is just dealing with Python, they know how to play with it, but they're not familiarized with quantum. So we want to give the chance to this kind of people or professionals or data scientists or even computer scientists that can jump to quantum even easier than what Qiskit is proposing or Penny Lane is proposing. So we package feature selection, we package in one place quantum kernels, variation classifiers, everything in one package, and they can run everything with, I don't know, 2, 3 lines of code. This was the first approach of Falcondale like a year ago. Actually, this is available, and you can go and pip install Falcondale, the open source SDK. But at some point, we said, well, we cannot create a product from this. Let's maintain the open source anyway. We can even keep improving the open source. But at some point, we said, let's develop something unique. Let's create an algorithm that can work better for the industry and provide some utility using not directly quantum hardware, but quantum simulators. Because hardware are noisy yet, you cannot run some things efficiently. Actually, trying to run some really large data sets through the quantum kernel approaches is really heavy and can take hours or days to run in actual quantum hardware. So we decided to start playing with simulators. And at some point, we discovered that we're having advantage or utility compared with models that banks or neobanks or fintechs are using, like GVM or whatever. They're using gradient boosting or logistic regression, everything that they can use now, especially in the range of not so many data points, let's say 10,000, 5,000 in that range. Falcondale techniques and what we developed through some genetic algorithms to create quantum kernels was performing better than those. Okay. So we said, okay, let's create a product, let's create a company. Actually, some VCs start knocking our door saying, oh, you should create something because this is looking good. We participated in the Q2B in Silicon Valley. We were selected as one of the top 7 in the pitch challenge. We also present our algorithm and Falcondale, because we actually went through this process in Silicon Valley without the company being incorporated yet. So in January, we incorporated the company, and 3 months later, we were in Paris, in the Q2B Paris, presenting the algorithm. Now we are pursuing more the clients, the application, and we're actually having a dialogue with at least 4 fintechs and neobanks in different places of the world implementing this solution.
Yeah, so when you talk about fintech or like quantum finance in general, what are some common applications where you think quantum computing can actually help finance?
Yeah, of course, there are so many applications that are coming from the optimization side, which is not my preferred field because I think it's relevant, portfolio optimization or things like that. Or even if you go to simulation, things like option pricing or derivatives pricing. JP Morgan is doing this for a long time. Other banks are trying to play with it. My field is more related to the classification side. So when you manage to have a better classification using quantum techniques, let's say today in simulators, in a few months or years, potentially hardware, in quantum hardware, you can use this for fraud detection. You can use this for risk assessment in general, credit scoring itself. And when you say credit scoring, it's not only the decision, but also you need to discriminate people positively. Like say, okay, how we can apply, how we can approve more people, actually, how the portfolio could be better, how we can include more people in the finance, credit, and loans, and everything that should be related to that. Actually, Falcondale is more pursuing now the SMEs, the credit for SMEs, to actually help this side of the economy that are particularly underserved by the banks. But following your question, I think the part of applying QML can help you also to define how much credit line you need to give to a person for a credit card, for example. Or in a few months, this person is going to be in default or not, since you're analyzing their behavior. Or you should increase the credit line or decrease. So there are so many different use cases inside the underwriting umbrella or under the portfolio monitoring. Of course, I know that finance have way more things like optimization or simulation, like derivatives pricing, portfolio optimization, option pricing, and a lot of more applications. But in my viewpoint, and I think I respect a lot D-Wave and other companies that are doing a great job. And I know people really close to me that are doing incredible work in optimization. But I think this field is also overpopulated. Like D-Wave for too many years are talking about optimization, and we're still not seeing something like more close to be tangible. And most of the solution looks like more classical than quantum. So, but I think definitely there is a promise of quantum giving benefit through the optimization side. And I guess the same is for QML. I cannot say that we're running in quantum hardware today, so it's still classical, definitely. But I think QML will play a huge role in the side of classification.
So I say like these were the opportunities for quantum. So as a researcher or as a CEO, I mean, what do you think are challenges that you're facing for quantum finance or quantum computing in general?
I think there are a few. If you connect quantum with finance and the quantum techniques with the finance sector, there are a few things that could be interesting to explore. For example, the regulations. Okay. When you are playing with the data of a user, some of the banks, depending on the country, depending on the regulation, the compliance, you need to preserve and maintain the data in your facilities or have on premise. Some others are going to the cloud, which is more like, say, innovative for a long time. Some fintechs are going there anyway, but some traditional banks still have their own servers and they're managing everything very, very close. So sending information through a specific hardware outside of the bank could be a problem for them. But buying a computer and put this quantum hardware is really expensive for now. The other thing, more in the side of software, the QML methods, since we're playing with simulators until now, you have a shorter span to play with qubits. So you're not playing with 100 qubits, you're playing with 10, with 12, with 20. So if you have a data set of 300 features to train a model, you need to reduce that somehow.
Yeah.
You need probably to try feature selection or trying to use some dimensionality reduction techniques. So the data is less interpretable, right? So you cannot read the data properly at the end of the algorithm decision to say this person was rejected for A, B, C, or D. And the regulations sometimes require that. You should be able to say, I reject this person because this specific income or this specific the debt to income or this specific behavior in the last 6 months, whatever, right? But when you just have vectors or numbers, you cannot interpret that easily. So the advantage should be so big in terms of precision in the model that the regulators should start saying, okay, maybe we should assume that there is not so many interpretability out of this model, but the benefit is high because we are giving the chance to people that are not receiving loans, for example, to receive loans now, and we have more precise models for the profitability of the market itself. So I was hearing the other day the European Banking Authority giving a presentation about this subject, not quantum, but the interpretability of the models. And they said that the only way to change the regulation somehow is exactly like that. So we can actually start discussing. But if you just increase 1 point in Gini or whatever, they say, no, I prefer to use an XGBoost with a feature importance and I'm ready. So
Yeah.
even some banks require some more basic interpretations, right? Even manual, depending on the business. So if they are in the consumer business or if they are in the SMEs business. I think these two things, like how I'm managing the hardware, how I'm able to connect my infrastructure to a quantum computer, and how I manage the data in between, I think could be a subject. And the other challenge is about how we can actually interpret the models properly in a great decision. But just connecting quantum hardware with the finance sector or quantum software with the finance sector. In general, you and me know that the travel of quantum hardware itself is a long journey. We have news almost every week, but still there are some things that should be developed, and I think there are some of the companies are doing a fantastic job.
Yeah, I mean, hardware is one of the problems you have right now, while working on algorithms. And so, but I mean, from 5 to 10 years from now, probably say we have good hardware, better hardware at least. And how do you think, this progress in quantum hardware would start affecting financial industry, and especially, professionals who are, involved in finance sector?
I think something that I missed, I think a bit about the last question, and I will connect this with Jay, is probably one of the pending things is about creating algorithms. And creating algorithms can be seen as a twofold problem because one thing is how I create algorithms for the future. Actually, we have some like really good algorithms from the 90s that needs to be applied in quantum hardware that is not there yet. We know technically that should work, but we need to wait, right? Um, like Shor's algorithm, you know what I mean.
Yeah.
But in terms of algorithms today, how we can actually develop something that could work better in the current state of the hardware or in some specific hardware definitions, like some specific qubit creation and something like that. So we can start thinking about, okay, actually, we can do something with the machines today. We should create some algorithms to apply something there today This is buzzing my mind a lot because I think we should keep trying to do algorithms. All this testing, I'm not saying that will be beneficial or we can grab some utility, but I think we are relying so much in the hardware that we are missing the point to trying to create algorithms for today. And also, I think, of course, some other algorithms needs to be analyzed or defined for the next era. In terms of the difficulties for the finance sector or the banks about this evolution, I think it's a very gray area about when to start. Should I start now, like creating my skills about quantum, start training my people, start incorporating some things in the company now? And I think my opinion, of course, since I have Falcondale and I have seen this from very close, is something that should be done today. I think I'm not the only one saying this. Actually, BCG, a year ago, I guess, they presented a study, a survey, and an analysis that companies that start implementing quantum now, at least with some tests, simulated, inspired, whatever you call it, and start trying to test some things in real hardware or train their people, they will capture like 90% of the value in the future. Because if we have, this is available, if someone wants to, I don't know, read about it, it's BCG, it's open, you can search in the internet. And they say that because imagine that in a few years now, 2 years, 1 year, whatever, 3 years, we have a kind of ChatGPT moment, not that big, but important. And suddenly quantum is working better in hardware. So many people will jump to say, okay, I need to use it like LLMs now. Everyone wants to use LLMs. But the scarcity of professionals will be there in an extreme way. There's not so many companies providing quantum software and being profound about different industries. You can name a few because there is a really close like ecosystem compared with other industries. But when the time comes and everyone wants to use quantum somehow, or let's keep it this in finance, every bank, every neobank say, okay, I should have a big advantage if I'm using this. This is clear now. I need people. So the pricing will go high. You will not have enough people to work on it. And the hardware, it will perhaps be really difficult to access and expensive. So if you have agreements now, if you start training your people now, you can jump really easy to this like advantage or utility that you can have in, I don't know, 24 months or 36 months.
Yeah, like that was really insightful for me as well. And if I, like, this was for like banks and on everyone involved in finance. Say, what about common people? How would their lives will be affected, and should they care about all of these things, or?
I think I will go back to my first few phrases that I mentioned here. Is like, you should be worried, not worried, I will say you should be in alert somehow about what will be the next thing for humans, right? When we are playing with subatomic particles, we're playing with a very mysterious thing, right? We know how to use it, we're trying to do it with quantum, but this is defining our reality. You can jump to other things like simulation theories. You can jump to, I don't know, what is conscious. You can go very far from quantum computing. But I encourage common people to think about quantum like one of the doors that if you open it, you can start learning more about what is the basic things about our reality and how this can affect us in the future. So I think going in the quantum computing side is definitely something that motivates me, and I have a lot of passion about it because I mix both things, like the mysteries about how this can work and provide benefit, and the computer science and data science part, which is my passion as well. We have this mysterious thing that have superposition, entanglement. Position entanglement is a principle that we use for quantum computing, but the principles are coming from the quantum mechanics. So studying this is crazy and trying to understand better. And I think I heard a person the other day, a researcher, that said when they received this question of what will happen if quantum computing at the end will not work? Imagine in 10 years this is not working, it's not adding value. Nonsense. The researchers said we will learn a lot in the journey about this subject itself, and this is beneficial already. So if you think in that way, it's not about quantum computing only. It's about the principles behind and what we can discover from there. I think this will be a passion for everyone.
Yeah, I mean, personally, I feel that the mystery that quantum mechanics holds, quantum computing holds, makes it really interesting for everyone. One of the researchers that I was talking to had this question that if I talk about particularly for quantum machine learning, that we are just trying to fuse quantum computing into the classical AI. But what the researcher was arguing that rather than doing that, we should just use classical AI to advance the quantum computing. Rather than fusing quantum computing inside classical AI, rather you should try to use AI to aid quantum computing in the progress in quantum computing. So like, what's your take on that?
Yeah, I think this is, I imagine already a lot of headlines talking about quantum plus AI everywhere because everyone is talking about it, especially how perhaps even quantum computing can boost generative AI, AGI, whatever. So there is a lot of people talking about it. I think there is a not clear path yet, actually. I don't think that I'm one of the people that said quantum is not for everything. A lot of people are saying, probably in the media, more or less, that okay, we will have quantum computers in our mobiles, right? And this will happen, I don't know, really soon. So I don't think that every classical approach will be replaced. But I think there are promises to start having utility from quantum computing, perhaps for AI. But I think even for error correction or other things that people are researching, machine learning techniques or some AI techniques can be beneficial. So I think we will have this cross benefit between both, but not trying to say quantum will replace something of classical or classical will replace something from quantum or one should serve the other somehow. I think they go through different paths. I'm actually studying, for example, a lot neuromorphic computing, which is another technique and another way to create chips. Actually, Intel is working on that for a few years now. This, again, I think could be another alternative that could be, they are saying actually that neuromorphic computing could be really beneficial to train LLMs or generative AI. I think there are a misconception about saying we should say that this will serve the other, or we should say that they will combine a specific position, but quantum is essential or not essential, neuromorphic could be essential or not. I think there is not clear yet. There is not an answer yet how this can perform in the future, but it's definitely promising that having more different computing power or different computing approaches can benefit to the develop of the economy as a whole, and the lives of the people can be improved somehow.
Yeah, so you just talked about LLMs and AI. One of the aspect that is being talked about a lot about AI is the responsible AI part.
Yeah.
And when you talk about finance, it's a very delicate subject for like economies, everything. And when such a delicate subject is being affected by this progress in quantum computing, should we also be concerned about something like responsible quantum computing or something like that?
Yeah, I think the quantum computing, neuromorphic computing, AI, etc., at some point needs to be part of an already regulated scenario. I think quantum computing will not be anything different from machine learning or classical machine learning in the way of how it should be regulated. Because at the end, we are providing in the future solution that could be faster, efficient, and more precise. So at the end, we are not changing the game in the way that the decisions are made. The AI is a little bit different because it's about including bias, it's about protecting data. It's really sensitive, right? Because, like, again, the techniques that I'm applying today with QML potentially in the future could be different, but I think will perhaps could be the same. Quantum machine learning techniques are really similar to just use machine learning. The difference is the chip that I'm using, but the outcome is kind of the same. The treatment of the data could be similar with different encodings, but at the end, we should have some interpretability better, things that are not solved yet in quantum. But this is already something that is regulated. This is something that requires that the bank, the neobank, and fintechs needs to show to the users or show to the regulators or some entity that is requiring this. But in terms of AI, I think it's different. We will introduce something that can have hallucinations, that can have weird behaviors somehow, that can have some bias. So I think AI is kind of in a process to be regulated for a long time. And now that is affecting not only finance, for example, like it's a really sensitive area, but let's say healthcare, for example. So you are deciding if you are deciding if someone have cancer or not, or they should take some medication or not, or somebody can die actually if you take the wrong decision. So in these terms, you need to be closely reviewing what is happening, how the process goes. In terms of quantum, if you lose, like the risk that I already said to you, is that if you're losing a bit the interpretability, perhaps this could be an issue. So we need to work on it. But the rest, I think, is really similar to what we're doing today with classical computing, but boosted somehow with quantum.
Okay, so like again, getting back to the neuromorphic part and all of that. So we can just talk about your upcoming book,
Sure.
Unconventional Machine Learning. So I mean, the title is really amazing. So can you talk about like what are the topics that will be covered in this book, the target audience?
Yeah, the concept of unconventional computing is not new. It's actually, they already exist, and we can talk about neuromorphic or quantum or analog computing for a few years. But we, with my co-authors, Tomás Tagliani and Irais Montalbán, we started to think, okay, let's try to go deeper, but not in unconventional computing, but in unconventional machine learning. How we can actually take advantage of this today, and what will happen, I don't know, in a few years. So first of all, the book is designed to not only go to the technical people. So our idea is to start with an introduction about what is quantum computing, what is neuromorphic computing, what is unconventional computing at the end. And from there, go and explain if we have some algorithms to play with in machine learning with those technologies, or the inspiration coming from those technologies, how these algorithms will work and how will be beneficial. We will provide some code about it. So even if you're a layman and you're not technical, you will have some snippets to start saying, okay, I can do something with Python and start playing with it. And also, we are having some good cases. You will see in the book, Jay, that even using some really early techniques in neuromorphic machine learning is providing value for some cases in the finance sector. So I think there are a few things that are really promising. And the other things that we're including in the book, since this is not for only technical people, is now that you understand what is unconventional computing, quantum computing, and neuromorphic computing, and some techniques about machine learning using these principles behind, how you can integrate this through to your current stack, right? How you can integrate this with your infrastructure. So we start mentioning who are the players on hardware side, who are the players in the infrastructure in general, how you should leverage the skills of your team. So start recommending things. For this book is for different industries, or even very new startups or companies that are just being created, how they can start testing those things and discovering by themselves that could provide advantage compared with the classical approaches. That's the book in a few words.
Yeah, that sounds really interesting. I'm buying the book.
Amazing,
So
amazing.
like,
Hmm.
yeah, so probably the most important question, the final question for podcast,
Hmm.
that if a student who is watching this podcast right now, pursuing a degree in computer science, physics, finance,
Hmm.
and is interested in quantum computing or quantum finance, what advice or roadmap you would give as a senior researcher in the field?
Yeah, I think there is a misconception about that everyone should have a PhD. Since this is coming from the academia and some labs there, a few companies actually in hardware or software are spin offs of universities. That's why you think you should be an expert on this. But I think quantum, of course, is not that mature yet. I mean, quantum computing ecosystem, but is increasing, and you need more types of different professionals. You don't need the one that have all the knowledge about the theory, but you need people that can code something or provide software to it or start some specific things about doing even business with quantum things, right? So being in a commercial position, knowing about quantum computing. So there is a really open situation these days, and I think this will keep growing, about different types of jobs that you can do in the quantum ecosystem. Not everyone should be expert like I said, or have a PhD, but you can be a quantum computing engineer or software engineer for quantum computing or data scientist knowing about quantum computing and their techniques and so on and so forth. So I think there is a lot of different areas that you can go. It's really frequent for me to receive messages through LinkedIn saying, I want to learn about quantum computing, what I should do. And I said, what do you want to learn specifically? What do you like the most? No, I'm data scientist. Okay, so you have a path for that. No, I really want to go to the hardware side. Okay, you have a different path for that. Or no, I want to be just people that can share information inside my company about it. Okay, you have a different path. So I think if someone is just hearing this, what I suggest is trying to first not go to the books right away and say go to the more complex one like Nielsen and Chuang or things like that they will go to a very complex scenario. Trying to go to the things that are more close to you. If you are a data scientist and you are coding in Python, jump to Qiskit. And Qiskit had a lot of information available, a lot of courses. They are creating videos now really recently and producing things really interesting. Penny Lane or trying to play with Circu or I don't know, they start testing things. And from there, start to saying, okay, I need to learn a bit more about some subjects that are interesting and jump to some books or jump to some other courses. But you don't need to pursue a PhD in any case. If you want to do it, perfect, amazing. But you don't need it. You can learn from everywhere. And the courses are there. There are things in Coursera, in Udemy, in edX. So there is a lot of different sources that you can have. And please don't feel the wall of I cannot understand this. This is too complex, and I need a PhD. You can learn from today. In a few minutes, you can actually grasp a bit. Okay, this is how it works in general. Actually, Jay, you are doing an amazing job. I think your videos. I like the one that we comment right in LinkedIn about these animations and everything that you did. Is amazing and really clear. And actually, if someone don't understand anything and start looking at these videos, okay, I now understand a bit more. And it's just, I would say just, but it's a lot of work behind. But it's just a video in YouTube that is available for everyone for free. So I think, again, I recommend your channel in YouTube. It's amazing. And I think it's just to be curious and you don't need a PhD.
Yeah, thanks a lot for appreciating my work on the YouTube channel. And yeah, that was really insightful. I mean, if I talk about myself, I've got some really new and fresh perspectives on quantum computing and mostly on quantum finance. Thanks a lot for your time and sharing your views with us.
Right? It's a pleasure to be here, Jay.